How was the weather this summer? Did you sweat through record heat? Did you watch snowfall somewhere it usually doesn't? Did you feel like spring or fall was unusually short or unusually long? You don't have to answer yes to be aware that the weather on Earth seems to be changing. Storms seem more intense. Heat waves seem more frequent. Maybe you heard that 2024 was the hottest year in recorded history. Parts of Mali hit 48 degrees. Parts of Mexico peaked at 52. Well, perhaps peak is the wrong word, because the truth is that all of this is just the beginning. Now, many are asking, what will life on Earth look like in 100 years if this trend continues? Scientists aren't the best marketers. Because they tend to couch everything they say in boring terms, we, the public, miss out on some very shocking information. You may have heard that the global average temperature is increasing, but this sounds abstract, like just another number. What does it mean? So scientists measure by combining millions of data points collected from across the planet, on land, at sea, and in the atmosphere. They then calculate for anomalies, or the difference between current temperatures and a baseline average. While they sound innocent, those anomalies tell us a lot. Behind every increase lies billions of tons of energy trapped in our atmosphere. For instance, the main figure you hear is that the Earth's average surface temperature has already risen about 1.2 degrees Celsius above that pre-industrial baseline. You may also have heard that if this number hits 1.5, we're in for big trouble. You wouldn't notice a 1.5 degree change in a room, so how can it destroy the world? One of the big reasons is that the extra heat supercharges our weather systems. That means more floods, more droughts, and stronger hurricanes. Hurricanes feed off warm water, creating stronger, wetter, and slower-moving storms. Take Hurricane Patricia in 2015. That storm's winds reached over 350 kilometers per hour. This passes the limits of what we thought was the strongest possible storm, Category 5. There's no Category 6, but if trends continue, we'll need one. Scientists are already informally calling them super hurricanes. And that's just part of the weather equation. For every 1 degree Celsius of warming, the atmosphere can hold about 7% more water vapor. That means when it rains, it pours. And when it's dry, it's bone dry. The equation is a simple one. Warmer air equals more humidity equals heavier rains and massive floods. That's how we get stories like Dubai's, which in April 2024 saw roughly 1.5 years worth of rain in a single day. You might also look at Africa, where some regions saw their first snowfall in living memory. You could search footage right now of South African lions walking through snowdrifts. And that's not normal. This isn't global warming, it's climate chaos, a violent mood swing on a global scale. Of course, its effects aren't limited to land. In 2021, the foreign minister of Tuvalu, a small island chain in Oceania, gave a speech to the United Nations while standing knee-deep in ocean water. Some dismissed it as a stunt, but it was more of a warning. At just 2 meters above sea level, Tuvalu is likely to be the first landmass swallowed by rising sea levels. In fact, the country signed a pact with Australia to allow for widespread relocations. And these small ocean countries aren't the only ones at risk. Imagine needing scuba gear to visit Venice, Bangkok, and Miami. Well, it's slowly becoming a reality. Sea levels are rising for 2 reasons: melting ice and the thermal expansion of seawater. As water warms, its molecules expand, meaning the same amount of water takes up more space. Combine that with the rapid melting of glaciers and polar ice sheets, and you've got oceans swelling faster than coastal cities can adapt. Current estimates say that if all the world's ice melted, the sea would rise by about 70 meters. That's enough to drown much of Europe and Asia's coastline. And the irony? As salt water invades our lands, fresh water will become rarer than ever. Here's a wild statistic. Only about 0.5% of Earth's water is both drinkable and accessible. The rest is locked in ice, underground, or floating in the sea. And right now, about 2 billion people, or 1 in 4 humans, lack access to safe drinking water. This is already a crisis of epic proportions. But once again, it's only going to get worse in the coming decades. Let me guess, you have an idea? If the oceans are rising and fresh water is dwindling, why don't we just make seawater drinkable? You're talking about desalination, which is a thing. However, this process is not only expensive, but also rare. Right now, desalination plants can only meet about 1% of global demand. This, as we literally flush our toilets with drinkable water while others walk miles to find it. For an idea of what we might be facing, consider when Cape Town almost reached day zero in 2018. In the lead up to this event, people were limited to just 25 liters per person per day. In 100 years, water might not be something that flows endlessly from a tap. It'll likely be more like Mad Max, where every drop is rationed, traded, or even fought over. If you're thinking that your grandkids can just hop a flight to higher ground in a few decades, think again. Like the land and sea, the air on our planet is also changing. As the poles warm, the temperature gradient between them and the equator weakens. That disturbs the jet streams, which are basically invisible rivers that pilots rely on. The result? Chaotic airflows that make flying a nightmare. Already, turbulence has doubled over the past few decades, and as emissions and costs become increasingly prohibitive, commercial air travel might become a rare luxury, or even obsolete. The good news is that they might be replaced by high-speed trains, but that doesn't do much good for that trip to Italy. At least you won't have to worry about seeing Venice. Air travel's nice, but it isn't a necessity. Food, on the other hand, did you know that for every 1 degree Celsius of global warming, crop yields for staples like rice, wheat, and corn drop by 5 to 10%? Add droughts, heat waves, and floods to the mix, an entire harvest could collapse. Some foods will simply vanish. Avocados and coffee require too much water, so savor those avocado toast brunches while you can. Beef, meanwhile, will become a luxury. You probably have no idea that each kilogram of cow meat requires about 15,000 liters of water. The good news in this case is that humans can adapt to a wide range of diets. Just know that in the future, your dinner plate will look pretty different. Yeah, your kids will most likely be eating bugs, the steak of the future. As a major source of protein, iron, and magnesium, we might have no choice but to chow down on worm burgers, cricket flour, and mealworm pasta. If that sounds like a health hazard, don't worry. You'll have bigger things to worry about than a bad grasshopper goulash. We're not talking about new diseases, though those will definitely happen. Instead, we're focusing more on the ancient ones. As permafrost melts, it releases trapped bacteria and viruses that have been sealed away for tens of thousands of years. And it's already happening. In Siberia, melting tundra once exposed anthrax spores that killed reindeer and infected people. Meanwhile, as temperatures rise, mosquitoes carrying diseases like Zika, dengue, and West Nile are migrating north. The same goes for ticks, which are now thriving in regions once too cold for them, spreading Lyme disease and tick-borne encephalitis. Even nature's smallest creatures are following the global trend, bringing old problems to new places. All of this makes living 100 years from now sound terrible, right? Well, the good news is that most of humanity isn't content to just stand still and watch this happen. In fact, we're already experimenting with ways to cool the planet. Some ideas are surprisingly simple: painting rooftops white to reflect sunlight, or covering glaciers with reflective blankets, which is a real experiment already tested in Switzerland to slow melting. Then there are the radical ideas. We're talking about geoengineering on a planetary scale. One idea is to release stratospheric aerosols to reflect sunlight. In this case, the goal is to replicate Mount Pinatubo's 1991 eruption, which cooled Earth by 0.5 degrees Celsius. Other ideas involve seeding the ocean with iron dust to trigger plankton blooms that absorb carbon, or building giant orbital mirrors to deflect sunlight. These are high-concept ideas, sure, but they come with consequences. Some of the predicted side effects include acid rain, ozone damage, and toxic blooms. In the end, we can't tech our way out of everything. Let's be clear about one thing: Earth will survive. It always has. The question is, will we? Scientists say humanity has already crossed 6 of 9 planetary boundaries, including climate change, biodiversity loss, deforestation, and freshwater depletion. In doing so, we've destabilized the systems that keep our environment balanced. So maybe the real message isn't save the planet, it's save ourselves. Because the planet doesn't need us, but we still need it. So where does that leave us? It's not too late, but we are running out of time. If we don't act now, life 100 years from now will be measurably worse. Heat waves, droughts, destructive storms, lack of food and water. That's not a life most humans can survive. And now that you know this, what will you do about it? Because change doesn't start with guilt, it starts with awareness. Next time you pour a glass of water, step outside on a summer day, or sit down to breakfast, remember, these are the simple gifts we're fighting to keep. The world in 100 years depends on what we do in the next 10. And that future, for better or worse, starts with us.